Today's video will describe how to implement the standard template library's set. Hello, I'm James Helfrich. The set is a really cool data structure that allows us to store a collection of elements. The cool thing about it is that we can find if an element is in the collection in logarithmic time. And to do so, we use something called a binary search tree. This video will describe how that's done. So let's take a look at the standard template library set. First, we're going to need to _include set in order to have access to that container. And then we're going to create a set by using std : set of int, a set of integers. We'll call this S, and we're going to create 10, 20, 30, 40, 50, use the initializer list to have a collection of elements. Just for fun, I will also make a set iterator at begin. Now, when I break into the debugger, let's see what this does. And notice I have my set here, and I have all the elements in sorted order. And then if we look into the raw view, we're going to see that weird element tree. This is a binary search tree. We can also take a look in the iterator, and the iterator also has a pointer to the element, and there's the element itself, and this also is a pointer to a node in a binary search tree. Okay, let's take a look at how we're going to implement the set using a binary search tree. Now, we're going to do this with a UML class diagram. We always start with, well, the set, that's the name of the class, and it's going to have a constructor, a copy constructor, an initializer list constructor, and a destructor. Basically, all containers should have something similar. And because we're a container, we're going to have an assignment operator, a swap, a clear, a size, and an empty. No big surprises there. Now, a set allows us to insert and erase things in logarithmic time. And I'm going to insert what? A T, so this is a template class. I'm also going to be able to find an element in logarithmic time, and I have to begin and end iterator. So, those return iterator, so I need to have an iterator class, and this is going to be a nested class within the set, so it's set : iterator. Now, my question is, how am I going to implement this guy? Well, like we alluded to before, with a binary search tree. So I'm going to have a single attribute of type BST, which means I need a BST class, which is a nested class. And notice the full name is set : BST. Now, the set iterator is a public nested class. In other words, the client can create an iterator object, but the BST is a private nested class, which means only methods within the set can access or reference my BST class. Now, how many BSTs am I going to have? It's related by association, and that association is composition because my set is going to create and destroy my BST, and there's always going to be exactly one in my class, so the numerosity is 1. Okay, now the BST itself has a single attribute, which is a root, and that root is going to point to a BNode. So I need to have a BNode class, which is going to be a nested class within my BST. Now I need to point out that neither the BST nor the BNode needs to be a nested class, but it's usually best to do so because there's no reason why the client should be aware of that implementation detail for abstraction reasons. Okay, so the BNode is a nested class within the BST, but there's also another association between the BST and the BNode, and that association is composition because the BST is going to create and destroy every BNode in the collection. And how many BNodes will there be? Well, there'll be many. And even though the root is a pointer to a single BNode, that root will also point to other BNodes, and so there's many in the collection. Okay, so what goes on in this BNode? Well, I'm going to have a data element of type T, which means I'm going to have this T, which is, of course, the template variable, and it's going to be related to my BNode through association, and that association is composition. Why? Because the BNode is going to create and destroy every T in the BNode. And there's always going to be exactly one T in my BNode. Now, there are 4 other attributes, at least in my BNode, and those include my pointer to my left element, my right element, and my parent element. And each of these are other BNodes. Now, if I create a single BNode, that does not mean I also create and destroy my left and right and my parent. I only refer to them. So therefore, my association is aggregation, not composition, and there's going to be 0 to 3. 0 when I'm the only node in the collection, 3 when I have both a parent left and right node, and of course, I could have 1 or 2 in various other configurations. Okay, let's harken back to my iterator. My iterator is going to have a constructor, it's going to have a copy constructor, but it will also have a non-default constructor which takes a BST iterator as a parameter, and it'll have an assignment operator. I'm also going to be able to compare two iterators, see if they're equals or not. I'm going to be able to increment and decrement. In other words, my set iterator is a bidirectional iterator, goes both ways, and I'll be able to dereference it. And what am I going to dereference? A t, which is my template variable. This means my set iterator must have an attribute, and this attribute, it turns out, is a BST iterator. So I'm going to call it it BST to differentiate it from a it set. Now, this BST iterator I have not yet defined, and it's going to be a nested class within the BST, not within the set. And so my set iterator is going to have an association with my BST iterator. And that association is composition because I'm going to create and destroy the iterator. And how many am I going to have? Always exactly one. Okay, let's take a look at this BST iterator itself. It's going to have a single attribute, which is a pointer to a BNode. And that pointer is going to refer to a BNode, but it's not going to create or destroy a BNode. In other words, if I create an iterator, I don't create a node. If I destroy the iterator, I don't destroy the node it refers to. I'm just referring to it. Therefore, my association is aggregation, not composition. And what's my numerosity? It's 0 to 1. 0 when I have the end iterator, and 1 when I'm referring to an actual BNode. Most of the methods within the set are actually trivial because they're just calling BST methods. Let's see how they work. First of all, if I'm going to copy insert a single element, then all I have to do is insert the BST, and I'm going to make sure that is unique. In other words, I don't want to have duplicate elements. And that'll return a pair, the element plus whether or not it was uniquely inserted, and I'll return that pair. Set's find method is simply going to call BST's find, and it will return, well, BST's find will return a BST iterator, but I got to convert that into a set iterator, which the client will use. Erase a single element. Well, first I got to find it. So I'm going to get a BST iterator from find. And then if it's the end iterator, in other words, the element is not in the collection, then I'm going to return 0, which means I deleted 0 elements. Otherwise, I'll erase it using the BST's iterator, and then I'll return 1 because I've removed 1 element. And even the initializer list constructor. Well, first of all, I'm going to clear my BST, and then I'm going to insert the elements one at a time into my BST. So all these implementations are done using the BST's methods. Okay, the set iterator simply contains an instance of a BST iterator like we talked about before. So the set iterator is a nested class within the set, and it has a single member variable, which is a itBST, which is a set BST iterator. So which means that most of the methods in the set iterator are trivial. So let's take a look at them for an example. The begin is just going to create a BST begin. And so I'm using my non-default constructor to create a BST iterator. My end is just going to refer to BST's end iterator. When I increment the set iterator, I'm just going to increment the BST's iterator. When I decrement it, I'm going to do the same thing. When I want to compare two iterators with each other, I just have to compare their it BSTs. And if they're the same, then they're good to go. And finally, when I dereference it, I'm actually just going to dereference my BST's iterator. So as you can see, every method in the set iterator is trivial. It's just a thin facade between the BST's iterator and the needs of the set. We can learn more about the implementation details of the set in the implementation section of the set chapter of the C++ data structures textbook.